So yeah, just a quick shout out to the core team here. Chuou is going to be presenting with me a little bit later. Marty's not presenting with us from our Seattle ZGF office, but has been a huge proponent of developing this tool to where it's gone to today. So a big shout out to him. And basically, we're framing this presentation as looking at both the upstream and the downstream calculations that can be incorporated into kind of current LCA tools and methodologies. So starting with the typical LCA scope, you've got your different boundaries and also the different modules of that LCA. And so as part of our research with the University of Washington, we identified sort of 3 different areas of potential improvements. The first being sort of like understanding a little bit better the biogenic starting point comparisons across these different boundaries and across different tools. So whether you're using EPDs from EC3 or you're looking at LCA software like Tally, just understanding like how different those can be, we thought it was definitely a useful starting point. And then the second one, adding in the forest, so looking at Bree's work in Miller-Hole and trying to incorporate a streamlined way to calculate those into kind of a typical LCA, kind of scale it up to making those calculations accessible to the industry at large. And then also looking at sort of custom end-of-life scenarios where we can start to actually dictate the split of incineration versus demo versus recycling based upon sort of like at this point it's design judgment and understandings of how the building goes together. So after identifying those areas, we sort of been developing this tool with the University of Washington that we're calling Upstream. That starts to actually do those calculations in a very easy, accessible spreadsheet format. And it basically uses Tally to be able to conduct the full cradle to grave life cycle assessment, and then also allows you to look at the kind of EPD-driven analyses from cradle to gate, something that you would get akin from EC3. And then it adds in that forestry data, and then in the future, we're working on this currently, we'll be able to add in sort of these different custom end-of-life scenarios. Hoping to release this into the wild around Q3 of 2021, depending upon how Chuou's kind of second and third semester goes for her research, but we're going to provide a quick demo of this tool at the end of this presentation, just to kind of show everyone where we're at. So then now let's actually start with number 2, talking about the forest factors that we've included in the calculation modules of the tool. So in this case, now we're starting to include, the emissions from slash burning or the carbon sequestered on the landscape, and then how that compares to the carbon, in the product through the entire life cycle. So we really needed to have both, right? What's happening to that biogenic carbon as it flows through the LCA, and what's happening to the carbon on the landscape, and incorporating that factor into the calculations. So this is sort of dives a little bit deeper into that net neutrality assumption that Bree had introduced from the ISO 21930, that's saying that, the North American forest carbon stocks are stable. So we have this net neutrality assumption where basically the growth over time equals the harvest that's taken out of the forest. And this is uber simplified, not scientifically drawn in terms of the slopes and the disturbances, but just to illustrate this concept of what this net neutrality means in terms of the carbon on the landscape over time. So this is one version of that, right? Where growth equals harvest and the average doesn't change over time, right? Everything sort of equals out. But really, when we start to think about also what Bree had said is that it's really a range of different things, right? So in some cases, you've got forests or stands that are increasing their carbon stock, and there's some that are depleting it. And if those two equal out to be average, stable, then that is just sort of like not super useful in terms of the goal, which is trying to, buy wood from landowners that are actually increasing the amount of carbon they put on the landscape and incentivizing that in the demand, as Jesse had mentioned, in terms of creating a domain for sustainable forestry. So this net neutrality assumption sort of obscures the differences and the variability within those scenarios that don't allow us to make decisions on, choosing good forestry. And of course, the reality of this is that it's super messy, right? There's all the different forests and all the different harvest methods and types across the landscape. But if we sort of squint our eyes and let's just assume all the carbon stocks are going up, like the UNFCCC reference says, then there's still variability within that, right? And the kind of slopes of these lines in terms of how much carbon these different landowners or forests are putting on is meaningful, right? Because the differences or the slopes of those lines, sort of look at what is the amount of carbon drawdown, right, from the atmosphere that we want to be tracking in terms of meeting all of our goals around climate change or our project's climate goals as well. So the idea is we need to identify sort of what these different factors are per forest, then somehow include them into a calculation. So if we just sort of take one example, and we look at that change over time from some type of starting point, it's very sensitive to like what is that baseline condition. But if we sort of set some guidelines around that time horizon, take that average carbon stock change, divide it by the wood product output, you can come up with an embedded carbon factor, per volume of wood product based upon its representation or its proportion to that overall slope or how much carbon was put on the landscape over time. So this is sort of the basis or the core of these types of forestry factors, and there's like a million different kinds, but this is sort of where the research has, at least in terms of being able to use it for LCA, in terms of taking that value and then putting it into a tool that allows you to specify volume of product, multiplying it by this factor, and it gives you the carbon either sequestration or penalty based upon that particular data set. So that's sort of the background and sort of like what carbon stock change is, because that's sort of the factors that EcoTrust was looking into. And they sort of have three versions of these factors that they've been evolving from their sort of watershed paper that Bree mentioned, which sort of looked at that sampling and simulation of the different forest dynamics. And essentially, they've sort of moved on from that initial study because that was sort of looking at carbon offset accounting, sort of what you would find in some of the California voluntary market protocols that tried to account for everything in a single factor. So they actually had their own factors for end of life, the biogenic carbon in the product and its decay over time. They also accounted for market leakage, all in sort of one number. And it wasn't a good fit for like, how do we as practitioners use that number in relationship to like the tally output or the EPD numbers? They didn't quite fit together. So they derived the factors that Bree used in her study from that initial paper, and they looked at a simulated net ecosystem carbon balance, where they more narrowly focused in on just the carbon stock change in the forest. And this is all the above ground biomass, which we know is missing out a portion of 50% of carbon from Jesse's presentation. But, the scope was limited to be able to actually do the calculation. So this is just what's happening, with the trees on the landscape. And they sort of left leakage to other types of analyses, and then the biogenic carbon in the products they left to the EPDs or the other software. So this actually allowed us now to separate this sort of A0, what we're calling, from the rest of the LCA, and actually have that their scopes aligned to be able to include them in a single analysis. And as Bree mentioned, sort of with these factors, we're able to analyze between Washington and Oregon, sort of the legal minimum scenarios versus FSC in a long and short rotation. So we have those currently baked into the tool. And then sort of the newest round of data that EcoTrust is working on, which is really exciting, is sort of using this sort of observational biomass data they're taking from sort of the NASA Land Trend or like carbon monitoring program. And they're actually able to use the satellite imagery to determine what that biomass change is. So that gives them their stock change. And then they're looking at county-wide timber output reports that are available at each county to come up with the output, and then using those to come up with a series of carbon factors by county, by landowner type. So it can actually be at the state level or the county level, and maybe even the individual landowner level, depending upon what data they can disclose and bring to the table. But this requires sort of a disclosure ask in the procurement strategy to understand sort of where your wood comes from, and what county in this case, to be able to apply these factors. So in one direction where this could go is where the concrete industry has gone. They had their static EPDs originally for like a certain mix, and they created a dynamic EPD where you could modify the ingredients, or in this case, the landowners, and it would come up with a carbon factor that you could use in your calculation. So, a lot is sort of going on and moving with this, but it's an interesting thing to try to track and be able to calculate from. So that's sort of the forest factors, and we'll sort of show those in the tool demo. But then kind of jumping back a bit, because once we started to dive into the forest carbon, we're like, well, where do we start from, right? Like your starting point makes a big difference as well. So this is where we started to try to understand the end of life scenarios between just sort of three different types of very common analyses. The first one being what you would get straight out of EC3 or just looking in EPD that follows that net neutrality assumption. They're basically saying the biogenic carbon in the product is all released at end of life, so it sort of neutralizes itself. And so then the GWP emissions is positive, all from the A1 through A3. So this is one starting point that's pretty common. The other one is if you look into the EPD, they do provide a long-term carbon sequestration scenario where they use the PCR rules to define a 100% landfill scenario. And sort of all the different carbon flows that go into that, equates out to a net long-term sequestration they claim in the EPD for tools that want to, point to it and use that in their analysis. You can see that's a pretty big swing, right? It's basically around 84% of the biogenic carbon is net long-term sequestered using that very sort of oversimplified assumption of 100% landfill, using the EPA WAR model to determine those flows. And then when we look at TALI, which has its own set of end-of-life assumptions, in this case, whoops, this got moved over. It's like 14.5% recycling, 22% incineration, 65.5%. Is landfilled. That gives you sort of a different long-term sequestration scenario. And they also include the fossil emissions from C2 through 5 as well, which also equates to another penalty. So the TALI data is sort of more comprehensive in its scope, and it's also using different end-of-life assumptions, which drastically change the sort of net amount of sequestration, as you can see, between just -480 versus -683. So it's sort of a big difference depending upon, which one of these sort of baselines you're starting from. So we wanted to at least have in the tool the ability to compare these so you can actually do like a sensitivity analysis on how that works out. And we'll dive into these a little bit more with the demo as well. And then I'm going to let Chuou talk a little bit about the custom end-of-life scenarios that we're working on.
As Jake mentioned, the 3 current available end-of-life scenario baseline from wood. However, due to the downside of those in the version 1 of EPD, the neutrality assumption underestimate the carbon saving. And if all wood in the version 2, if all wood waste treated as a landfill, oversimplify the diverse paths. And with Upstream LCA tool, we're hoping to give the designer the flexibility to have custom input based on your design decision. In this comparison, TALI has the fixed percentage for wood waste treatment based on the 2014 municipal waste report. And we aim to allow custom end-of-life input while using the same conversion factor and provide disaggregate emission data from for fossil and biogenic emission by using the EPA WAR model. And next. Next slide, please. Thanks. So in TALI, 14.5% of wood is treated as recycled. And as our timber reuse case study, the Federal Central South project, we were able to harvest timber from a warehouse. The salvage lumber was used as structural member, decking, finishing, and landscape material. Our study estimates 76% as timber recovery for the structural member, 81% recovery for the decking. In this unique project, we use the beam as it is, which contribute to the high recovery rate. Otherwise, 40% is a good rule of thumb for reprocessing based on our conversation with the lumber consulting. And I'll hand it over to Jake for a teaser of our tool.
Yeah, thanks. Thanks, Chuou. Yeah, it was interesting to see that, with TALI, if it's 14.5%, what's the carbon impact of ratcheting those numbers up based upon, in this case, that was a very intentionally designed competition for this office building based upon what was available in that warehouse. So it sort of represents the highest end of what could be achieved, at least with reusing timbers. What's that mean for CLT? What's it mean for glulam? And what's it mean for the overall end-of-life carbon flows if we can start to modify or do sensitivity analyses around that. So here's sort of a view of the tool currently. It's basically a spreadsheet, right? We're sort of working on all the attributions and the disclaimers. We're filling out the documentation that sort of goes into the different scoping and what data sets are used for each one of the modules, because it sort of gets spliced together in some cases. So we have to be super clear about where the data is coming from. But we really try to make it as simple as possible in terms of, green is user input. So you can look at all the different kinds of products that the tally EPDs could output. So let's just stick with glulam. You can sort of choose your volume of input units. And in this case, I'm just going to kind of go along a case study that we've been looking at, which is just one of our office building kind of prototypical studies as well. So it's roughly 40,000 cubic feet, converts it to meters cubed, which is what all the conversion factors are based on. You can add a baseline case, so you can start to understand its reference to like a steel case. So in this case, it's like 2.5 million kilograms of CO2 is just what the steel case came out to be. And then it starts to give us a way to compare. And then we get into all the different module calculations. So for instance, it asks you if you want to include this module. You can turn these on and off essentially in the tool in case you don't want to use them, depending upon the scope that you want to do for your analysis. It allows you to choose what kind of EPD. So in this case, we'll just take the US industry-wide. And then these are the glulam EPDs that we've pulled down that you can include. There's sort of old legacy ones, and then there's the latest ones from the American Wood Council. So let's choose the 2020. We also allow you to choose the regional LCAs behind this. So if you wanted to do Southeast versus Pacific Northwest versus Canada, those are also in the tool. They're all pretty close though. And then this is how, which biogenic carbon methodology do you want to do? So if we do sort of this, not reported, it just sort of shows that A1 through A3. We can also choose the kind of net neutrality assumption, in which case we're tracking those flows now to where there's a biogenic carbon in the product and it all gets emitted in C3 through 4. So it actually kind of makes it more visible what's happening with those biogenic flows, which we thought was useful. And then if we go to their kind of version 2, the long-term sequestration, this is that 100% landfill scenario where there's only a small amount of net emissions. So there's a pretty large carbon storage benefit. I think this is a bit over predicting, but this is baked into this EPD and ISO standard. So we've seen it used for analysis. And then also there's the tally with and without. So here's the tally biogenic scenario, which references that split from the 2014 municipal waste report before getting into the fossil emissions of the other end of life scenarios. So this sort of allows you to sort of see those differences in the spreads and how that's starting to get calced out. And it's showing us sort of our savings from our reference case. We can include transportation or not in here. Custom scenarios, we'll just skip some of these because we're getting close on time. C2 through 4, since we're choosing tally, we want to be consistent in terms of choosing all the tally with end of life. Same thing with module D. And just to kind of back check, this is indeed positive, as Bree had mentioned, for all those kind of rule counting pieces of the way tally deals with biogenic carbon. So that checks out. And then this is where we get into the forestry calculations. So you can choose to include it. Right now, we only have eco-trust factors, but we're going to include sort of a custom input. And then as like FSC is working on kind of updated numbers and SFI, those will be able to get rolled into the tool pretty easily. But right now, it's just eco-trust. And then we have sort of the data set that Bree had used, the simulated carbon stock change or the observational. So we drop down to the simulated. We can choose the Oregon FSC short was sort of the best case scenario. And then it starts to actually calculate that sequestration benefit in that module. So that's sort of like all you would need to do as an architect to be able to start to understand the impact of the forest, which, streamlining this calculation we thought was pretty useful. And then of course, if you do have the disclosure data, you can choose the observational biomass data, choose the state for which that came from, and then put in the kind of percentage of wood that came from, the different from the different landowner types, and then it recalculates accordingly what that forest factor is. And then also we included some things to be able to put in uncertainty factor if you're trying to match to EC3, and then also the ability to kind of add scenarios we want to build into the tool so you can kind of view results side by side, because it's sort of a lot of like drop down button clicking and then kind of coming back to this chart to kind of see what that spread is and sort of where those different data sources are. And then we're working on building out the calculation modules for custom end of life, which we will, then release the tool probably after that. So if you're interested in sort of being a pilot user, let us know. And then also we're going to probably try to use the CLF platforms and forums to have working groups that are piloting as well.